Plus 2 Physics Chapter 1 Electric Charges and Fields. Coulomb's law in vector form. The force acting on Q1 due to Q2. F12 equal 1 by 4 pi epsilon 0 Q1 Q2 by R square R12, where R12 is the unit vector drawn from Q2 to Q1. Similarly, the force acting on Q2 due to Q1, F21 equal 1 by 4 pi epsilon 0 Q1 Q2 by R square R21, since R12 equal minus R21, F12 equal minus F21. Note 1. Coulomb's law hold good only for point charges. 2. The direction of force is always along the line joining the 2 point charges Q1 and Q2. Hence, this force is called central force. Question. An electron and a proton are separated by a distance r. Compare the magnitudes, electric force with the gravitational force between them. Answer. Fe by Fg equal 1 by 4 pi epsilon 0 EE by R square divided by G MP ME divided by R square equal 2.4 into 10 raised to 39. That is, Fe equal 2.4 into 10 raised to 39 into Fg equal greater than Fe greater than Fg. Forces between multiple charges. Superposition principle. The electrostatic force between two charges is not affected by the existence of the other charges, and the total electrostatic force on a charge is the vector sum of all the forces due to other charges. This is the superposition principle. Consider a system of n charges Q1, Q2 and Qn. Then the total force acting on Q1 is F1. F1 equal F12 plus F13 plus etc. F1n. Question. Consider three charges Q1, Q2 and Q3, each equal to Q, at the vertices of an equilateral triangle of side I. What is the force on a charge Q with the same sign as Q placed at the centroid of the triangle as shown in the figure? Answer 0. Problem 3. A. 12 equal charges Q are situated at the corners of a regular 12-sided polygon. What is the net force on a test charge Q at the center? B. Suppose one of the 12 Qs is removed. What is the force on Q? Explain your reasoning carefully. C. Now 13 equal charges Q are placed at the corners of a regular 13-side polygon. What is the force on a test charge Q at the center? Answers A 0, B F is equal to 1 by 4 pi epsilon 0, Q capital Q by R square towards the missing charge. C 0. Electric field. It is a region around an electric charge where an electrostatic force is experienced on another charge. Electric field intensity at a point E. Electric field intensity at a point is defined as the force experienced on a unit positive charge placed at that point. Electric field lines. Electric lines of force. It is the path along which a unit positive charge would move, if it is free to do so. The tangent at any point on the line of force will give the direction of electric intensity at that point. Properties. 1. It starts from a positive charge and ends in negative charge. 2. Two field lines can never intersect each other. E. Electrostatic field lines do not form any closed loops. 4. Uniform electric field can be represented by parallel lines. Field lines due to some simple charge configurations. Electric dipole. Two equal and opposite charges separated by a small distance is called an electric dipole. Dipole moment P. The strength of a dipole is measured by a quantity called dipole moment. Dipole moment P is equal to Q into 2A. It is a vector quantity whose direction is from negative charge to positive charge. Unit Coulomb meter. Electric field due to dipole. 1. At the axial of a dipole. We are going to find out the EF At a point P which is at a distance r from the center of the dipole on its axial line, EF at P due to positive charge, EB equal 1 by 4 pi epsilon 0 q by r minus a the whole square P. E at P due to minus q charge, EA equal 1 by 4 pi epsilon 0 q by r plus a the whole square into minus p. So the resultant E at P. For an ideal dipole r square very much greater than a square can be neglected. Therefore, equal 2p by 4 pi epsilon 0 r cube, P equal 2p by 4 pi epsilon 0 r cube. 2. At the equatorial line of a dipole, perpendicular bisector, magnitude of E at P due to plus q charge. Magnitude of E at P due to minus q charge. Direction P to A. Since the magnitude of EA and EB are same, the vertical components cancel each other and horizontal components exist. So the resultant E at P, EA cos theta plus EB cos theta into minus P. E at P equal to EA cos theta into minus P since EA equal to EB. Also cos theta equal A by r square plus a square the whole into half. Dipole in an external field. 1. In an uniform electric field. Net force F is equal to minus QE plus QE equals 0. T is equal to QE into 2A sin theta. Torque equal to PE sin theta. Note: when an dipole is placed in an uniform electric field, total force is 0. There is no translational motion. Torque will tend to align the dipole with the field E. When P is aligned with E, the torque is 0. 2. In an non-uniform electric field. In non-uniform electric field, there is a torque and net force on the dipole. Thus, the dipole has rotational and translational motion. Electric flux. Electric flux through an area is defined as the total number of electric field lines passing normally through the area. The flux through an area is given by the product of the area and the component of electric field perpendicular to the area, parallel to area vector. Electric flux through small area dA is given by the total electric flux through the area A is given by unit Newton meter square divided by Coulomb.